Well, hello again everybody. I'm kind of at that point now where I've got just too many things on the bench, all in parts, all in pieces, so I thought I would better just repair a few things and get them screwed back together, and then they can go on the dusty shelves and remain there for the next 10 years. So I've ordered a load of parts from RS, and it's come with the usual ridiculous amounts of packaging. So there's the evil tantalum capacitors, some new electrolytics there. What else have we got? Some large main electrolytic smoothing capacitors. And, well, some more electrolytics. All with an unnecessary and large amount of packaging. I don't know why RS do that. I don't think it's very green. I seem to think the DEFCON was moaning about that. Scott was having a whinge about all that packaging the other week. So we've got here this Thandar TG502. So what we're going to do is we're just going to replace some of those duff capacitors and well, it was the tantalums and the main smoothing capacitors that were bad. But I thought while I was in here I might as well replace the rest of the electrolytics as well, because after 30 or 40 years, which I'm not sure how old this equipment is, I think it's 1980s, so I guess after 30 years it's probably due for some capacitors being replaced, isn't it? So rather than replacing just electrolytics and then going back next year and replacing a few more, I might as well just do the lot all at once. Well, I don't know if you'll remember, but we did identify that this tantalum capacitor here had gone short circuit, and because that had gone short circuit, this resistor here, which is kind of a current limiting resistor, it's designed to protect the output stage, because that tantalum had gone short circuit, it actually drew too much current through this little resistor here, which then burnt out and it let the smoke out. But while I had the thing in bits, I did actually do a couple of ESR checks on some of the other capacitors, and they weren't bad, but they actually weren't that good either. They were on the way out. So yeah, I'm going to replace some of them while we're at it. Now, unfortunately, it's not going to be super easy to get at some of these components, in that there's actually two boards here. There's one installed on the opposite side of the board as well. There's one installed underneath. So, yeah, unfortunately, I've got to take this board off to actually get at the board to unsolder these capacitors. Oh, I've just noticed somebody's been in this before. Some of these screws are loose, so yeah, that wasn't me. Okay, well I think I've disconnected everything now, apart from all the things I've actually forgotten to disconnect, so that's always a good start. You know what? I don't think that's going to get me where I want to get to, having disconnected them. I've disconnected a lot of these wires underneath, but I've just actually spotted an aluminium plate under here. So it actually looks as though I'm not going to be able to get at it, which is really annoying. A lot of these screws feel a bit loose. I think somebody's had a go at this before me and, to be honest, just given it up as a bad job. And yeah, already I'm starting to see how they feel. It doesn't take much to put me off, in fairness. I'm terribly lazy. I know I've said many times before, I don't actually like repairing things very much. I like playing with things. I don't actually like repairing stuff. So am I going to be able to get that out? No, this thing really is. It's going to fight me all the way, isn't it? I wonder if I can see underneath if there's an aluminium board separating them. Yeah, there is. I wonder if I can just get this board out if I release these front screws. That's interesting. Now we've taken the frequency control knob off, can you see how the this plastic has gone yellow? I think that's some kind of chemical effect. It's some kind of bleaching that occurs, because it isn't actually, well, it is a bit dirty, but it's not the reason it's gone yellow. Is it something like the bromine in the plastic reacting? It's something like that, I believe. Come on, what's holding that now? That's got us where I want to be. It's this board that I'm mainly interested in. So let's plug the solder sucker in and start sucking away, eh? Well, I think, as Dave Jones would say, some of the wiring on this thing is definitely a bit how you doing. So we've got the mains wiring here, and it's actually pressed up. It's actually clamped up against the main board here with because there's this screening plate that goes on top of here. So this wiring is actually compressed on top of the circuit board. And obviously, being a PCB board, it has got sharp, pointy things sticking through it. So you can really kind of imagine that it would be quite easy for you know, one of the PCB legs, one of the component legs, to stab into one of these mains wires, and then you'd have mains voltage on this low voltage board. That could really ruin your day, couldn't it? I was just double checking myself then, because I put these two capacitors in, and when I look at it I can see that we've got a ground plane here. Now, one side of the ground plane we've got a negative connection, which I thought you would you know, expect. We've got a negative arrow. But on the opposite side of the capacitor, it's a positive side. So I just had to think about that for a second, and I guess what we're looking at, we're actually looking at the plus and minus power supplies here. You know, maybe, I don't know what it is, maybe it's plus and minus 20 volts or something, and then gets regulated down to plus and minus 15. So it's a centre tap transformer, and these are the ground connection is the centre point of the centre tap. The ground connection, sorry, is the centre point of the centre tap. You know what I mean, don't you? I don't have to tell you. You know better than me. While I'm doing those capacitors there, I am going to also just do these. What are they? They are 25 volts, 100 microfarads. So we've got 4 capacitors here. I think they're all the same. 25. What's that? 100 microfarad. 100 microfarad, 100 microfarad. So let's have all them out. Nope, that one came out easy. Next one. When a solder sucker works, it's a pleasure, isn't it? Absolutely a pleasure, but when they don't work, I'm not going to say that, I'm going to tempt fate. I'll shut up while it's actually still working. "100 microfarads, 25 volt. I better not fit these, because these are 35 volt capacitors, and as everybody knows, they might not work, because 35 volts, there's maybe not enough voltage to make these capacitors work. We really need to fit 25 volts, but they're all I've got, so I'll just fit them, eh? Sorry, I couldn't resist that. I just wanted to see if anybody would leave it in the comments. Somebody on the internet is wrong. Yeah, well. I did actually have some capacitors once, and I think I commented on that. Rather than having an arrow pointing to the negative leg, they had a band down the side of them. You see this little white band? They had a band down the side of them, but it had a positive symbol on it, and that's let me out before now as well. So let's just check that. Long leg positive. Yeah. Long leg positive. That should be on the left. Yeah. Long leg positive on the left. Yeah. Long leg positive, that should be on the right, and it is. Right, let's get them in. Solder one side down, then I'll straighten them up a bit. Oh, that's annoying. When I put one of them capacitors through, it's just managed to push up the pad. That's annoying when that happens. We'll have to try and smooth that down. In fact, all them joints I've just done, they all look a bit dry. That's not very good. The solder's just sat on top of the board. Didn't do a good job of that. So the pad on this capacitor is a little bit dodgy. When I pushed the leg through, it seemed to catch the edge of the pad and it's lifted it off. So what I'm going to do is I'm just going to do a bit of a billy bodge. I'm just going to leave the leg long. And I'm just going to solder it down to one component that's a bit further up the side of the board. It's a little bit bodgy, but yeah. IP certified me, you know. Actually, it's true. Back in the day, that day was a very long time ago, I'll tell you though. You know, I'm not happy with that joint. It looks a bit crap. I'll suck that off and have another go. Something about it, the solder just hasn't taken as well as I would like it to. So, just gonna have another go. Just using a little bit of flux on here. I've only started to use flux relatively recently. Most of the time I just persevere, but I think when you've got an old board it does just help. It just, the reason it helps as much as anything is you don't have to spend too much time you're soldering in contact with the pad, which, you know, risk damaging it. You wanna be in like Flynn, get in and get out quickly. You don't want to be scrubbing away to make sure you've got a good joint. So what we've got to do now is we've got to get on with the main feature, which is actually just replacing all these really nasty, evil, bad tantalum capacitors. So I just need to take off our bodge wire. Ow. So I think that's the one that was shorted out. I think that's the one. It's either this one or it's the one behind it. I cut them both off. You've got to be sure, haven't you? Yeah, that is the offending tantalum. This is almost what I'm talking about. So tantalums, they have a stripe down them, but rather than denoting the negative wire, often the stripe denotes positive. In fact, I think all the tantalums I've seen, the stripe generally means positive. But if you're looking for a stripe on capacitors, it just seems strange that they chose the opposite convention. The electrolytics have a stripe down them pointing to the negative leg, whereas tantalums have a stripe down them pointing to the positive leg. So, you know, what's all that about, really? Honestly. Throws a bone, somebody. I've got a feeling this won't come out on camera, but I said that one of the pads, when I was soldering it, one of the pads broke off, and unfortunately I had to just bend one of the legs of a capacitor a bit longer and take it to the next pin to solder it onto. But interestingly, I can see here that somebody has been in here before me, and I can see some damage to the board here. And somebody's done just the same thing. They've taken the leg of a transistor, and rather than cutting it short, they've had to bend it, and they've soldered it onto the adjacent pad because it must the pad's actually fallen off. So I'm only guessing that the adhesive or whatever on these pads is well, they're actually quite small pads. You know, they're relatively fine tracks and quite small pads. So I'm guessing that you know, somebody else has been here and they've just had the same problem as me. They've been trying to repair something and they've put a bit of heat onto the board, and the pads have just lifted. Right, so that's all the tantalum's done now. So I'm fairly pleased to have got that done. Just check that. Positive, 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 and positive. Is there any other tantalums before I move on to something else? Nope, so that's all the tants and all the electrolytics now changed out on this board. Alright, we've got to do this dodgy resistor, this R119, which if memory serves me correctly should have been 10 ohms. I'm fairly sure it was 10 ohms, so we've got to put that I'm going to put another one back in there. So I've just been and found a 10 ohm resistor. I'm just going to install that. It look as though they're quarter watt, something like that. I did for a moment think about putting a bigger resistor in, but I think it's better to let this resistor burn out if it's going to, because you know, it's maybe a little bit sacrificial in its function. And I'm quite happy to sacrifice the odd resistor if it you know, stops doing any more permanent damage to anything. Yeah, definitely not really happy with the way this board's taking solder. Seems a bit strange. Maybe it's just dirty, but it, yeah. I'm not using different solder. I'm using the same temperature that I always use. But I don't know. Just something about the joints doesn't look as good as I would like. Okay, that'll do with that board. Put that out of the way and we'll change the electrolytics on the other board. If you guys have got something more important to go and do, I suggest you go and do it, because this is not very interesting, is it? So what have we got? What are these? We've got 10 microfarads, 35 volts. So what have I bought here? 10 microfarads, 63 volts. 100 microfarads, 35 volt. 10 microfarads, 63 volt. So I think we'll use them. Just checking all the capacitors have got symbols on the board, because it's nothing more annoying than pulling a capacitor off and then find out that they've forgot to put the legend on. So you're then scribbling around trying to work out again what the polarisation is. Yeah, they're all on. So we should be able to whip these out fairly quickly with a bit of luck. And guess what? It's blocked up again. I've just come to unsolder one of the capacitors here, and it was already unsoldered, so yeah, I think Billy the Bodger's been in here, hasn't he? I don't know if you can see that, but you can see how wrinkly these tracks are, and I don't really understand what that is. I don't know if it was some kind of thermal expansion problem when it went through the reflow solder, but it isn't the solder resist there that's giving that crazy pattern. It is actually the tracks that are all wrinkly under it. They almost look like they're falling off. So yeah, I don't know what all that's about. Well, I've got no doubt that I'm going to be able to reassemble this now with only a modicum of totally foul language. So let's see how that goes, eh? So it could be in like Flynn. This really is quite an unpleasant thing to work on. Right, there was a ground cable going across here somewhere, wasn't there? I can't see where it's going. Oh, there it is. Oh, okay. Well, that could have been worse actually, couldn't it? Doesn't feel as though I've quite got the board sat down yet though. Oh, there we go, maybe that's gone down. Okay, that didn't feel too bad. That didn't feel too bad. Maybe we've got away with it. Well, after a considerable amount of wailing and gnashing of teeth, I've managed to put this thing back together, and I have actually been rewarded with some sweep action. So thanks very much for keeping me company this evening while I've recapped this Thandar TG502 generator. I hope you didn't find it quite as mind-numbingly tedious as I did. So until next time, I think that'll do. Thanks for watching, see you again soon. Bye bye for now.